Hey everyone, it's Mr. Aarons. Today I'm actually recording a two-part study guide. So this will be split into 2 days. This will be your Wednesday and your Thursday. So I'll tell you when there's a break here, and then you can take a break and you can finish watching it tomorrow. So I'm just going to do a few problems from the study guide. Just try to hit the basics, and then you're going to do the rest on your own after I complete this video lesson, or if you're watching this in person. So I'm going to jump right ahead to number 5. I think the ones that I'm going to do are going to help you along with the other ones. So I'm just doing a select few here. Looking at number 5 here. So right here we have a lot of x's, and we need to try to solve for x, obviously, because that is our only variable here. So our way to do that is first simplify this problem. My step number 1. I'm going to use this right here, and I'm going to distribute. Take this 3 and distribute. I like to do that first. So if you're looking at the next one, you're going to distribute there first. Distribute first. 3 times 3x is going to get me to 9x. 3 plus 1, or 3 times 1 is 3. Okay, now I've got it set up like this. I'm looking at this side. I know I can simplify this a little bit. I have 2 plus 9x plus 1. I can connect these two together and make it 9x plus 3 equals 9x plus 3. Some of you are probably looking at that right now and think, oh, I think I know what's happening here. And I hope so, because if you notice, these are the same on each side. And whenever they get to the point where they are the same on each side, this means one thing. Identity. No matter what we plug in for this x, it'll be the same for this x. Watch what I do here. Minus 3 from each side. That'll cancel that out. Cancel that out. 9x equals 9x. Divide this side by 9. Divide this side by 9. Cancel that out. Cancel that out. We have x equals x. Anything is going to be true. This marks an identity. Remember those identities. Remember those no solutions. Refresh yourself on those if you need to. All right, looking at the next one, we're going to jump ahead to number 7. We've got x plus 5 over 6 equals 15. Right, whenever I see something on top like this, I like to put an imaginary brackets there, because I know I can't pull this apart quite yet. So what I'm going to do first here is I have to figure out how I'm going to get that x by itself. Whatever I do to one side, I got to do to the other. I got x plus 5 divided by 6. I'm going to try to get closer to getting that x plus 5 by itself. So I'm going to times each side by 6. That'll undo the division. These cancel each other out, leaving us with x plus 5 equals 15 times 6. Pull out my calculator real quick so I can keep this video a little shorter. We got 90. Finally, to get that x by itself, subtract 5 from each side. X equals 85. All right, we're flipping to the next page. Moving on to number 11. All right, we talked a little bit about this one. We've got 2 fractions. Sometimes right away we want to say, oh, let's multiply by 3, get rid of that. But then if we do that, we have to multiply this by 3 and this by 3. That's a lot of multiplying by 3, a lot of fractions. It could get sloppy. So instead, what we are going to do is we are going to try to find a common denominator to make this a little simpler for us. So I'm looking at these and I'm thinking, a common denominator between both of these. I know one right now. I know it's 12. I got 3 and 4. We're doing common denominators, so I'm going to make them both equal to 12. And multiply that out by 4. Whatever we do to the bottom, we have to do to the top. 4 times 1x is going to be 4x over 12 plus, in order to get this to 12, I'm going to times this by 3. Whatever we do to the bottom, got to do to the top. 9x, got 9x right there, over 12. Right now I can add these together real quick. 4x plus 9x is going to be 13x over 12 equals 20. Okay, now that's something that we can figure out here. I'm thinking this top part's locked in. Not going to do anything with that yet. So the first thing I'm going to do is cancel out this divide by 5 or divide by 12. And in order to undo a divide by 12, well, we're going to multiply by 12. Cancel those out there. Gets us to, let's see, 240 over here. Now we got 13x equals 240. Our final step to get x by itself, divide by 13. Gets us to a decimal. It's about 18 and a half, but I'm just going to leave mine as 240 over 13. Took those steps to find the common denominator and moved from there. All right, moving on to number 13. Right here we have proportions. We worked on this last week. This is where we want to think about our cross multiplying. We're taking this times this. We're taking this times this. Whenever we have two fractions that are equal to each other, we want to cross multiply to find those missing parts. So what I'm going to do 8 times 1 is 8 on one side. 2 times 5n plus 1. I'm going to write that out just like that. 2 times 5n plus 1. From here, we're going to distribute. You can't just do 2 times 5n and then add the 1. You got to make sure you distribute it here. That's going to get 10n plus 2 equals 8. Get that n by itself. Start by minusing 2. Gets us to 6 equals 10n. Last step, divide each side by 10. And I can simplify that to 3/5. 3/5 equals n. Donezo. Cross multiply on all those proportions. We're going to have a couple more examples of that coming up here. Your next one's actually going to be similar to that. And these ones down here. Saw some of these on your homework. We have similar figures. We have 7 length here, 10 length here, 13 length here, x right here. They're similar figures. So we can set this up as a proportion. 7 to 10 equals 13 to x. It's our time to cross multiply. Let's do it. Hit those. Hit those. We got 130 equals 7x. Last step, divide by 7, divide by 7. And we're going to need another fraction here, so I'm just going to leave mine as x equals 130 over 7. Using that cross multiply on all those proportions. If you're talking about heights of different things, distances, that works for all of them. Moving on to number 16. We got a little conversion here, a little metric conversion. Actually, not metric, but conversion. So we have, write the speed of 33 miles per hour in feet per second. So we're converting units. So I'm starting with 33 miles per 1 hour. That's how I want to write that out. 33 miles per hour, 33 miles per every 1 hour. And we're going to convert that to feet per second. So first, we have to convert this to, it's our choice. We can either convert to feet first or to second first. Let's start by converting to feet. So I have miles on top. Our trick here is if we're trying to convert from something, we move it from top to bottom or from bottom to top. So if we're moving from miles, we're going to move diagonally down. Watch what I do here. Might make more sense. I got miles on top right now. I'm going to move it to miles on bottom. I want to do those diagonally. Then I will be able to cross those out. So I know, you might not know this, but I know that 528 feet is the same as 1 mile. I got miles on top, miles on bottom. We can cancel those out. We converted to feet now. Now we have feet per hour. We have to get to feet per second. So we have to convert this hour to seconds. I know it's going to take a couple steps. Some of you might be able to do this in 1 step. I'm going to do it in 2. I have hour on bottom right now. I need to get hour on top. So I'm going to toss hour up here. 1 hour on top. 1 hour is the same as, let's get a little closer to seconds. I'm going to go minutes first. 60 minutes. Okay, cancel out those hours. We're now to feet per minute. We need to get to feet per second, so I need to put this minutes on top so I can cancel it out. So I'm going to get minutes up here. I want seconds down here. 1 minute is the same as 60 seconds. We can cancel out those minutes. We now have feet per second. All we have to do here is a little bit of multiplication. We're going to have 33 over 1 times 5,280 over 1 times 1 over 60 times 1 over 60. And that would give us our final answer. I'm going to punch that one in real quick. And I would get let's see if that simplifies it all. I have a feeling it's not going to, but it might. Nope, 48.4. 48.4, and then we got to make sure to include our unit on there. Feet per second. If you struggle with that one, might be worth going back and looking at the conversion video again. Scrolling back a couple weeks. Number 18. I think this is going to be our last one for the day. Yes, this is going to be the last one for the first part of our lesson here. Number 18. The formula for area of a circle is A equals pi r squared. They want us to solve the little equation for r. That means they want us to get r by itself. This is going to seem tricky because we don't have a lot of different variables in here. But our goal is just going to do this the same as we always would. Imagine these are numbers if that makes it easier for you. I'm getting r by itself. Right now I have A equals pi times r squared. To undo this pi, I'm going to divide each side by pi. That'll cancel those out. A over pi equals r squared. To undo a square, we're going to do the square root. So I'm going to undo that by doing the square root of these. That's going to cancel these out, leaving us with the square root of A over pi equals r. Done deal. Just like that. We're just worried about getting r by itself. Do whatever you need to. All right, that is your last one for the first part of the lesson. I'm going to keep going so I don't have to post 2 videos, but you're welcome to stop for the day and start up again tomorrow at 12 minutes 45 seconds. I'll make a note of that in the Edpuzzle notes. All right, day 2 here. Working on part 2. I got a few problems for us to do again here. Our first one that we're going to look at on the part 2 is down here. I'll rewrite our Pythagorean theorem, because that's what we're using for this one. They tell us to find the missing side length. They give us 2 of them. They give us A is 9, C is 15. They don't tell us B, so I'm going to plug these right in to where they should go. A is 9, so I'm going to do 9 squared, plus we don't know B, so we're going to leave it as B squared, equals C squared, which is 15 squared. Start to solve these. 9 squared, I know, is 81, plus B squared equals 15 squared, which is 225. To get closer to getting B by itself, we're going to subtract that 81 from each side. Gets us to B squared equals 144. To undo that square, take the square root. Whatever you do one side, you got to do the other. Those cancel out, leaving us with B equals square root of 144. Some of you are probably screaming at your heads. 12. All right. On to number 5. Oh, I shouldn't have this here. It's an old formula. We're looking at original price and new price. This was our last lesson. We did earlier this week, actually. So we have our formula I wrote down here for us. We have amount of change divided by original. Original minus new. I actually want this to be high minus low instead of original minus new. High minus low divided by original. And then we're going to multiply this by 100 because it's going to give us a decimal. So for number 5, we have our amount of change. What that really is asking us to do is find the difference between these two. The amount of change is going to be 45 minus 40 And then we're going to divide that by the original. The original is 45. 45 minus 40 is 5 divided by 45. Let's see what that is. We get 0.11111 repeating. In order to convert this into a percentage, our last step, multiply it by 100. Or if it makes it easier for you, you move that decimal place 2 times. So we move it once, twice. Right here, I'd move it once, twice. There it is. There's our percentage. We've got 11.1 repeating percent. Now you'll notice this is never positive or negative, so we have to look at it and figure out if this was an increase or decrease. The original price was 45. The new price is 40. This went down, so it is an 11.1 repeating percent decrease. We took our original, our high minus our low, divided by the original, times that by 100. Number 9, we're looking at some of our percentages. We have the is of. Worked on this last week. Let's crush it real quick. For this one, they give us 250% of what number is 60. So they tell us our is. So I'm going to plug that in for our is, 60 on top. And they tell us our percent. They already gave it to us right here, 250. So we're missing our of. So 60 over b equals, I'm going to plug that in for the percentage. From here, we got 2 fractions that are equal. Let's cross multiply. We got 6,000 equals 250b. Divide side by 250. And we get b equals 24. Worked on that last week. If you need a refresher on that, go back to those. All right. A hairdresser is considering ordering a certain shampoo. A company A charges $4 per bottle plus $10 shipping. Company B charges $3 per bottle plus $25 shipping. How many bottles must the hairdryer buy to justify? So what we're going to do is we're going to set these equal to each other. Did this a couple weeks ago. I think this is the last week that you're in person. 4 bottles plus $4 per bottle plus shipping. So I know it's going to be $4 for every bottle plus the automatic $10 shipping charge. That's what my one side's going to be. The other side, we got $3 per bottle plus the automatic $25 shipping charge. Now we have to just solve for B, something that we know how to do already. I'm going to start by getting all the B's on the same side. Subtract 3B from this side. From this side, we get B plus 10 equals 25 minus 10 from each side. B equals 15 bottles. After you buy 15 bottles, these would be equal to each other. All right. Some new information here again. This is what we worked on this week. We have, in 2005, a car sold new for $12,500. In 2008, the value of the car was $8,750. We're finding the percent decrease. I have this formula sitting over here for us. We have our high minus low divided by the original. Our high is right here. Minus our low. There he told us it was going to be a decrease. It was originally new for this much. Let's check it out. Divide that by 12. And we get 0.3. Our last step, in order to change that to a percentage, multiply by 100. and that will be a 30% decrease. That high minus low divided by the original, multiplied by 100 to get your percentage. All right, number 14 here is a little bit tough. The store's cost for a stereo was $27. The markup was 75% of this. A customer purchased it on sale for 40% off the markup price. We got a couple steps here. First, the markup was $75 of the cost. So what we're going to do, what that means is they bumped up the price. So what we're going to do is we're going to take 75 or 27, multiply it by 0.75. That's what that would be as a percentage, as a decimal, equals 20.25. That's what they bumped up this price. So they did 27 plus 20.25. This is a little tougher. I don't think you'll have anything this tough on your homework or on your test, but we're going to go through it. It'll be good practice for us. Gets us to 47.25. So this is where we're at now. The customer purchased it on sale for 40% off the markup price. So they purchased it for 40% off or for 60% of this price. So what we're going to do is we're going to take this, multiply it by 0.6, and we get our final answer of 28.35 That is how much they paid for that stereo. A couple steps to get there, but we made it. Moving on here to our interest problem. What that's going to look like is we have this formula here, our interest formula. Think about that in your head for a second. Right now we know that we have interest equals principal times rate times time. All right, what this is going to look like here, we have $13,000 deposited into the savings account. Right away, I know that is my principal. That's my initial amount. So I'm going to set that in for P. Interest rate, right here, 6.5%. How much money will be earned after 3 years? There's our time. Let's set it all in. We got 13,000 times our interest rate, 6.5%. I have to write that as a decimal, so I'm going to move this decimal place 2 times, and we would get 0.065 times our time is going to be 3 years. Plug that in. And we get an interest of $2,535 after 3 years. Using that formula, go back and review that if you need help on it. Number 19 we're moving on to. We got a little bit more Pythagorean theorem here. Determine whether the given lengths can be side lengths of a right triangle. Right away, I'm thinking I'm going to draw my right triangle. I don't care if it's proportional or not. And I also know right away that 85 has to be this one. It is the biggest. The biggest is always going to be that diagonal. 77 down here, 36 over here. Pythagorean theorem should be 36 squared plus 77 squared equals 85 squared. Let's check it out. 36 squared, 1296. 77 squared is 5,009. 85 squared is, let's see if it checks out. And it does. This works out. So yes, those can be. Last one, and I'll let you to work here. We're looking at distance formula. I included a video of this last week on your quiz if you need a refresh on that. Basically what we're going to do here is we're going to plug our points into this formula. So we start by taking this right here. We have our x, our y, our x, our y. This one is, we'll count these ones as 1, we'll count these ones as 2. So we took our x2, which is 12, plug it into the first spot. Our x1 is -3, plug it into the second spot. We take our y2, which is 7, plug it into this spot. We take our y1, which is this one, plug it into this spot. Now all we got to do is simplify and check it out. 12 minus negative, that's the same as plus. That's going to be 15 squared plus 7 minus 3, or minus 4 is 3 squared. I know these ones in my head. Gets us to 234. That's all still square root. Check it out. That's going to be what our D equals. It also is about 15.29. Done deal. Just like that. All right, there you go. There's the part 2 for you. The test, part 1 will happen tomorrow. It's a 2-part test, so it'll be the next 2 days. You'll do part of it Friday. The next part you'll do on Monday. Come back. You're allowed to move to and from in this video. Good luck with this. Good luck with your tests.